my dear learners, for this course on engineering graphics. In this module 4, we were discussing on development of lateral surfaces of solids. So far, we have solved 10 problems on development. Moving ahead, the problem number 11 of our discussion states that a frustum of a pentagonal pyramid, smaller base sides 16 mm and bigger top face sides 32 mm and height 40 mm is resting on the horizontal plane on its smaller base, with one of its base side parallel to vertical plane. Draw the projection of the frustum and develop the lateral surface of it. We have a frustum of pentagonal pyramid which is in its inverted position because it is resting on the smaller face of 16 mm side and the top face have 32 mm side. So since we have an inverted frustum of pentagonal pyramid, let us leave space on horizontal plane to determine the apex of it, because since we have frustum of a pyramid, the development is based on true slant edge. To extract the true slant edge, we want the apex. But what he has specified is just the frustum details, that is bottom face and top face are at a distance of 40 mm. Both bottom and top face are pentagon, and side length of bottom face is 16 mm side and top face is 32 mm side. Since bottom face is of lower dimension, we will get a structure like hopper. So like this. So this is what he has specified. If you look at it from top, both the faces are pentagon. He has given like this. So you have to find the apex. I want to extend this further, this side further, I will get the apex. So therefore, I want more space in the horizontal plane. So analyzing this problem, let me draw front and top view of the given problem first, and later we will move on to the development of it. First, if I solve for top view, let us draw the top view, for which I will fix the reference line XY and mark vertical and horizontal plane. This is X and this is Y. Let us take, we have vertical plane, we have horizontal plane. Now either I can solve by taking edge towards right and corner towards left, or I can keep edge parallel to VP, or I can take edge towards right side and take corner towards left. Anything is correct, but a careful observation reveals that is clearly stating with one of its base side is parallel to VP. A careful observation reveals that with one of its base side should parallel to VP. So I should draw one of the base sides should be parallel to VP, then only I can construct. So therefore, first let me lay down the side which is parallel to VP, using which I will construct the pentagon. So we have the top face 32 mm side pentagon, bottom face 16 mm side pentagon. So the top view I will get two pentagons. One is of 32 mm side, another one is of 16 mm side. So first let me draw the outer pentagon which is of 32 mm side. So if I solve for that, first let me draw 32 mm side length. So drawing 32 mm and drawing 32 mm side length. Using this, I will construct the pentagon by angle method. You know that interior angle of pentagon is 108, whereas exterior angle is 72. So interior angle is 108 or exterior angle is 72. Similarly, mark the angle here also. Interior angle is 108, mark, or exterior angle is 72. Now using these angles, construct the remaining two sides. So draw 32 mm again. So draw 32 mm again. Similarly here also you draw 32 mm. Draw 32 mm. Now using compass complete the pentagon. That is, measure it and cut arc. So measure this and cut arc. From here also cut arc to intersect. So this completes the required pentagon. So I constructed the top view of this top face. So this is the top face pentagon of 32 mm side. So let me mark this as A, B, C, D and E. Now identify the center by drawing perpendicular bisector to the opposite side from each corner. Similarly from here I will draw a perpendicular bisector to this side. Measuring the center, I will draw a perpendicular bisector from here. So this is what the center O and O1. Now since this is a pyramid, connect from all the corners to the center. Is to say that the slant edges are visible in the top view. Done. Now the bottom face of this is 16 mm side. So I should draw one more pentagon, bottom face of 16 mm side. So for which first I will mark 16 mm by taking 8 on either side. Identify 16 mm on this one. So I identified 16 mm on this one. So since it is converging hopper like structure, the inner face is invisible. Clear? Now once you draw 16 mm line on these two slant edges, between these two slant edges, if you connect 16 mm, identify 16 mm such a way that 8 on each side, then it is very easy to complete the pentagon. Just you measure this and keep cutting the slant edges. So intersect the slant edge like this and like this. Now if I connect, I will get one more pentagon of side 16 mm each. Perfect. I will get 16 mm pentagon. One more. So I constructed 16 mm side pentagon also. That is, this is 16 mm side, this is 16 mm side, and this is 32 mm side. Let me show it here. This is 32 mm side. So we are done top face and bottom face. Hope it is clear. Now to find the front view of this hopper like structure, that is inverted pyramid, draw vertical lines from extreme corners, that is A and C. A and from C. Now this is at the top face. Top face is at a height of 40 mm. So draw 40 mm height. Draw 40 mm height. Draw 40 mm height. Now this is the bottom face. So take projection from the extreme corners. Let us call this as A1, B1, C1, B1, E1. take projection from A1 and C1. So we will take projection from C1 like this. So this is at the bottom face and this is at the top face. Now connect these two to get the frustum. This will give us the frustum. This will give us the frustum. So connect this. So this is the required frustum, that is A1, C1, C and A. Since front view, you mark it with primes. A dash, A1 dash, C dash, C1 dash is the required front view of the given problem. But we have to mark E1 to E, D1 to D, C1 to C and B1 to B. Now if I mark it will get confused. Let me stop at this point, complete the development and later I will explain how to get the correct front view of it, because he is clearly stating draw the projection of the frustum. He is clearly stating, so therefore I should show proper front view also. Now to go for development, as I said, for pyramids we want true slant edge. Here we have 5 slant edges: A2O, B2O, C2O, D2O and E2O. A careful observation will reveal that none of these slant edges are parallel to VP. So therefore none of them measure true dimension in the front view. So therefore I should make one of these 5 slant edges parallel first and then take the projection connected to the apex that will measure the true slant edge. Before that, let us identify the axis. So mark the apex point by projecting the axis of this problem. So I projected the axis. Now extend these two sides to get the apex. Extend these two sides to get the apex. Similarly, extend this side to get the apex. So get the apex here. So this is O dash, and here I get O. Let me call this as O1 dash and this as O dash. Now we got the apex point. Since none of these slant edges are parallel, neither A dash to O1 dash nor C dash to O1 dash measure the true slant edge dimension. So therefore, rotate and make O to C as parallel first. Rotate and make O to C parallel. That is, make this slant edge parallel. I have made this one and call this point as C2. Call this point as C2 and connect C2 now. Now extend C2. Extending C2. So I will get C2 dash here and this will be C dash. So I got C2 dash. So C2 dash to O1 dash is the true slant edge for us. So connect it. Connected. Now you measure C2 dash to O1 dash. C2 dash to O1 dash is the true slant edge. So if I measure C2 dash to O1 dash, it is measuring 85 mm. It is measuring 85 mm. So on this we want this also. So transfer this and measure till here also. So this will measure. This is measuring 43. This is measuring 43. So this is the required inverted pyramid, that is frustum asked in the question. Now I can make use of these two slant edge. We know side length as 32. So therefore first you draw an arc for unknown angle, then cut equal arcs at 32 mm side for 85 mm length. That is, if I move for development, first I should take 85 mm dimension. So measure 85. Measured. Now fixing a center. Fixing a center. Draw an arbitrary arc. Arc for unknown angle. Now measure 32. Measure 32 mm. Measuring 32. Measured. Cut equal arcs. Arcs at equal interval. 5 pentagonal. 1, 2, 3, 4 and 5. Done. Now connect these points, that is, this is A, B, C, D, E and A. So connect it to the center. Connecting it to the center. Connect it properly to the center. Done. So this is O. Done. Now we know from top it is 43, therefore from bottom it will be 85 minus 43 is 42. Measure 42. So this dimension is 42. From here to here it is 42. Measure 42. Measured 42. Now cut arc at 42. So just you draw an arc at 42 like this and connect. So this must measure 16 each. You can check. This will measure 16 each. Perfect. We're getting 16 each. 16, 16, 16. Here also we get 16 and finally we get 16. So now if I connect with sharp edges at 32, at the outer face it is 32, the outer face it is 32. Now you connect 1, 2, 3, 4, 5 and the closing set. So this is the required development. This is the required development. Same procedure is applied to solve for hopper. Now showing the measurements, we have from here to here it is 42. So remaining is 43. Now from here till here it is 85 is the true slant edge length, that is C2 dash to O1 dash. Now if I measure at the top between B to C or B to D, it is 32 and here it is 16. At the bottom it is 16. So this bottom portion is removed and top portion will be retained. So this is the required development. At bottom we are getting 16, at top we are getting 32. Perfectly we are getting the solution. This is how we should solve for hopper also. Hopper I will take in the next lecture. You might think that this is looking in larger in dimension, this is looking in smaller in dimension. To explain properly, I have used for this a scale of 2:1. I enlarged the diagram. So here I have used the scale of 1:1. Scale of 1:1. That is why it is looking bigger in dimension. This is looking smaller in dimension. Now I can stop at this point, but he is clearly asking to draw the projection of the frustum. So we have drawn the top view. So since it is a converging section, here also it will be invisible. Slant edges. Inner surface. Now take the projection for E and E1 first. Let me take for E1 and E. So take projection for E1. Taken for E1, take projection for E. Take projection for E. Now connect these two. This is E1 dash, this is E dash. So similarly we have BB1, so this is BB1, this is BB1, and then we have DD1, take projection for DD1. This is D1 and take projection for D also. So this will be D dash and this will be D1 dash. Here we have B1 dash, B dash. Right? Now since observable is at the bottom, you can see only A, B, C. You can see only A, B, C, whereas E and D are invisible, right? E and D are invisible to the observer. So therefore, E1 to E is invisible. E1 to E is invisible in the front view, and also D1 to D is also invisible in the front view. This concept you have clearly learnt in orthographic projection of solids. So for the observer, A, B, C is visible. A, B and C is visible. E and D are invisible. So this is the required front view, top view and development for problem number 11. This is how we should solve for hopper problem also, in which here we have solved for pentagonal pyramid, inverted pentagonal pyramid. This is because the top face is of larger dimension and bottom face is of smaller dimension. It need not be pentagon always. You can also give it for square, rectangle, hexagon, etc. You can try the same problem by taking hexagon with the hexagonal frustum of a pyramid.